Hello, today we're going to talk about predictions. How can we make predictions using probability? Before we dive in, how are you today? Great, let's get started. We're going to do a little bit of algebra review before we get into the predictions. We'll need these skills later. Let's look at number 1. What is 1/2 of 50? Well, here's how you do this. We take the 1/2. The word of means to multiply. And we just multiply by 50. So you can put this in the calculator. 1/2 times 50 is 25. Or you try it. Number 2. What is 1/3 of 15? When you do 1/3 times 15, you get 5. Number 3. What is 50% of 24? Now, you might be able to do this in your head because you know that 50% is the same thing as 1/2. But I'm going to show you how to do this algebraically. If I want to put 50% in my calculator, I need to turn it into a decimal. So I can use dupe decimal over percent. I'm starting as a percent, and I want to change this to a decimal, so I move my imaginary decimal point 2 places to the left. So 50% as a decimal is 0.50. You can also write that as 0.5. It's the same thing, but I'm going to leave it as 0.50. Of means to multiply, and we're going to multiply by 24. What is 0.50 times 24? 12. Same thing as 1/2 of 24. Let's try number 3. What is 15% of 120? First of all, what is 15% as a decimal? To do this, we put our imaginary decimal point there, move it 2 places to the left. So 15% is 0.15. Of means multiply. What is 0.15 times 120? Well, when we put this in the calculator, we get 18. Let's say for your 21st birthday, you fly to Vegas and start gambling. For this game, you win by landing on red. What is the probability you'll win? There's a few ways you can say this. We could say there's a 3 in 10 chance that I'll win. If I do 3 divided by 10, I get 0.3. Or I could say there's a 30% chance that I will win. All of these are the exact same thing. Now, I'm going to use this probability to make a prediction. First of all, in your own words, what's the difference between a prediction and a random guess? A prediction is an educated guess, something that you think will happen based on information. So, for example, for this game, you win by landing on red. The probability you'll win is 3 out of 10. Let's say you want to spin 100 times. Make a prediction about how many times you should win. So what do you think? If you spin 100 times, how many times should you win? Here's how you can figure this out. We are going to take our probability, any form that you want. I'll take 3/10, and I'm going to do 3/10 of the total number of times that I'm doing the event, which is spinning. So 3/10 times 100 is 30. So I predict that I will win 30 times. It's not a random guess. I use the information that I had from the probability, which was 3/10, to make a prediction. Let's talk about population versus sample. The population is the big group that you're talking about. So So if we were talking about our school innovation, the population would be every single person in the school. A sample is a small subset of the population. For our lesson today, we're going to have random samples. So a small group of students selected randomly from the school, for example, like maybe every 10th person that leaves the building. Okay. So let's say Justin wins at Uno 15% of the time, which is 3 out of 20. Let's say he plays 50 times. Predict how many times he would win. Justify your answer. So here's what we're going to do. We are going to take our probability, 3 out of 20, and we are going to multiply it by what we can call our population. Our population is our big number, which is 50. What is 3/20 times 50? You can put this in your calculator. What do you get? We get 7.5. You could either do 0.15 times 50, or you could have done 3/20 times 50. So we're taking our probability and multiplying it by our population. Let's do another one. All 20 students in Miss Rachel's 10th grade class put their name in a hat. Each day, Miss Rachel randomly selects a name, and that student gets to pass out papers for the day. If there are 180 days in the year, how many times do you think each student will get to be the paper passer? Here's how we're going to set this up. We want to know, what's the probability that, let's say, you will be chosen if there are 20 students in the class? So the probability is 1 out of 20. Now we're going to multiply this by the population, or the big number, which is 180. So basically, 1/20 of the time, you should be chosen to be the paper passer. What is 1/20 times 180? We get 9. 9 times. So for the whole year, you should expect to have that job about 9 times. Let's look at a blood type question. A random survey of 300 people showed these percentages for blood types. Let's say you have blood type B and need a blood transfusion. That means you need to get someone else's blood inside of you. And there are 500 blood donors today. How many people should be able to donate to you? So here is a diagram. This is actually true. If you have blood type B, which blood types can donate to you? So if you need blood, you can actually get blood from your fellow type B, because there's the arrow there. You can also get blood from blood type O. So can't get from A and can't get from AB. Can only get from O and B. So let's look at the pie chart. What's the total percentage of O and B that you can get blood from? So you can get from that 20% and that 36%. So because you can get from type B or O, I'm going to add my 20% plus my 36%. And what percent of donors is total? If we add 20 plus 36, we get 56%. If there are 500 donors that day, about how many people should be able to donate to you? We need to figure out what is 56% of 500. What would that be? To put this in your calculator, we need to change 56 into a decimal. There's our imaginary decimal point there. Boom, boom. Turns into 0.56. Multiply it by our population. And we put this in our calculator as 0.56 times 500. And we should get about 280 people from that group should be able to donate blood to you. Let's look at another table. This is called a frequency table. It just tells you how often something happens. So let's say Danette is taking a random lunchtime survey of streaming services. So we're going to be looking at a random sample here, no rhyme or reason. So we have 9th, 10th, and 11th, 12th, and she asked about Netflix, Disney Plus, and Hulu. Let's look at question number 1. How many 11th grade students watch Netflix? That would be 50. 11th grade watching Netflix is 50. How many 11th graders did the survey in total? Here's how you can do that. Just add up the total number of 11th graders. So in your calculator, you would put 50 plus 35 plus 15, and you would get 100. Question 3. What fraction of 11th graders watch Netflix? All you need to do is put the number of 11th graders that watch Netflix over the total number of 11th graders. So 100 is your total, and 50 was the number that watched Netflix. All right, let's use this to make a prediction. Let's say there are actually 350 11th graders in the whole school. Based on this small sample, predict how many watch Netflix. So I'll give you a hint. I want to put my probability here and my population here, and that will be my prediction. What do you get? So I put 50 over 100, and I multiply that by 350. So 50 over 100 is also the same thing as 0.5, or you could do 50 over 100 times 350, and you get 175 11th graders. That is a prediction based off of the information you got from your survey. Okay, let's do one more. A statistics class surveyed some students during one lunch period to obtain opinions about television program preferences. The results of the survey are summarized in the table below. We have male and female. We have comedy and drama. Based on the sample, predict how many of the school's 351 males would prefer comedy. Justify your answer. So I'll get you started here. If they said, predict how many of the males prefer comedy, what information don't we need in the table? We actually don't need the females. So now I'm going to talk about my sample. For my sample, I need a probability, which means I need some kind of total. How many males were surveyed in total? Well, we just add those up. 70 plus 35, we get 105. How many of those prefer comedy? 70. Now here I want to put my population, which they said was 351. So let's make a prediction. How many of those 351 males prefer comedy based on the sample? We do 70 divided by 105. Multiply that by 351. And we should get 234 males prefer comedy. So we're going to continue more on frequency tables next time. Just let me know what you thought of the lesson.